Hello, ladies and gentlemen. Let us look at Unit 9, Probability Review for the test. All right, the first part is going through the 5 probability rules. You will need to know the 5 rules of probability. Rule number 1, all probabilities go from 0 to 1. The symbols for that are 0 is less than or equal to p, less than or equal to 1. Rule number 2, if you take and add, or the sum of the sample space, if you take all the probabilities and add them together, they need to equal 1. So the probability of the sample space add them all up equals 1. Remember, probability cannot be negative, and it cannot be more than 1. Rule number 3, the probability of A, remember this is or B, this is the symbol for or, equals the probability of event A plus the probability of event B. But you have to subtract the union if they overlap the probability of A and B. Okay. Study your Venn diagram. That will help visualize it better. And we will do one later on in this packet. Okay, rule number 4. It's the complement rule. Probability that an event does not occur is 1 minus the probability it will occur. Okay, and then the symbol for that, you might see a little C here. The probability that event A will not occur is 1 minus the probability of that event, that it will occur. Rule number 5, for independent events, the probability of event A and B occurring is simply the probability of A times the probability of B. Now, again, they must be independent events in order to be able to multiply those together. All right, moving on. So you're going to spin each spinner once. How many outcomes are there? Well, there's 3 spaces on this one. There's 4 spaces on this one. They're equal in size. So 3 times 4 is 12. There are 12 outcomes. Number 2, list all the outcomes. So we simply list A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, C4. Okay, match each one up. Next one, what's the probability of spinning A3? Well, there's only one of them out of 12. So 1/12. Okay, the probability of spinning a C. Okay, just look at this spinner. There's only one out of 3, 1/3. A or B. Okay, again, just look at this spinner. A or B. That's 2/3, 2 out of 3. and then a number greater than 2. So just look at the spinner. Greater than 2, that would be 3 and 4. That would be 2 of them. 2 out of 4, which is 1/2. All right, moving on to the next page. All right, so in this situation, we have a college professor tells his class on the first day that there will be 3 tests in his class and 2 projects. He goes on to tell them only 50% will get an A on the first test. 40% will get an A on the second test, and 30% will get an A on the third test. Also, 70% will get an A on the first project, 20% will get an A on the second project. Assume each test and project are independent of each other. All right, don't forget, change percents to decimals. So the decimal for this is 0.50. That one, 0.40. This one, 0.30. This one, 0.70. And then this one, 0.20. All right, the first question is, what's the probability of getting an A on all 3 tests? That's an and situation. You get an A on the first test, and second test, and third test. Multiply those together. Again, that was rule number 5 on the first page. So you get 0.06 if you convert it to a percent. There's only a 6% chance you will get an A on all 3 tests. Not a very good chance. What's the probability you will get an A on the 2 projects? So you'll get an A on the first one and on the second one. So 0.7 times the 0.2, you get that. And that's only 14%. You get an A on all 5 of them. An A on the first test, second test, third test, an A on the first project and the second project. Again, that's an and. Multiply, 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 multiply. 0.0084, which is 0.84%. This professor is pretty hard. You have less than a 1% chance to get an A on all 5 of those. Now, the 5th question, got to think about this one a little bit. At least 1 A. Well, at least 1 means 1 or more. But that's kind of difficult because you might get an A on the first test, or you might get an A on the second test, or you might get an A on the third test. So this is not possible listing out all the scenarios. So we have to use the opposite or the complement. So what's the opposite of 1 or more? At least 1 A, 1 or more? That would be no A's. So we have to use the complement rule. 1 minus the probability of getting no A's will tell us the probability that you will get 1 or more. So what does that look like? Okay, we have to use the last answer to help us with this answer. So we're going to go 1 minus, okay, now the probability of getting an A on the first test was 0.5. So not an A is 0.5 also. The probability of getting an A on the second test is 0.4. So the probability of not getting an A on the second test is 0.60. Okay, that's what's left over. Getting an A on the third test is 0.30. So not getting an A is 0.70. Okay, project. Getting an A on the first project is 0.70. Not getting an A is 0.30. Getting an A on the second project is 0.20. Not getting an A is 0.80. Lots of complement rule here. So you have to go 1 minus this times this times this times this times this. Just type it in your calculator like that. You're going to get 0.9496 or 94.96%. So you have a pretty good chance of getting at least 1A. All right, let's move on. Suppose you have another professor that tells her class on the first day that there will only be 2 tests, a midterm and a final exam, and you must pass one of them to pass her class. She tells her class that only 70% will pass the midterm, 65% will pass the final exam, and that 40% will pass both. All right, now I've already got it drawn out here, so let me explain what I did. You always start with the middle. You always start with the middle. Now, 40% or point, I mean, remember, change your percents to decimals. I already did that. Change your percents to decimals. So 0.40 is in the center. Now, how do I get this? Well, you have to take your 70%, 0.70, and subtract the 40%, which is 0.30. That is what goes here. And then the final exam, 0.65, you have to take 0.65, take away that 0.40 again, and you're left with 0.25. Okay. First question. You will pass exactly 1. Exactly 1. So you'll pass this one, or you will pass this one, but not both. This one or this one. So 0.55. That's not a very good pass rate. Okay, exactly 1. You pass only the midterm. Well, that's that one. You pass only the final exam. Well, that's that one. You don't pass the class. Okay, well, first you have to take all 3 of these and add them up. This one plus this one plus this one. So this is passing the class. Okay, that's the 95% of the students are going to pass the class. But this one says you don't pass. So you have to use the complement rule, 1 minus the 0.95 and get 0.05. So 5% of the class will not pass. All right, let's move on to the next page. The voters in a large city are made up of the following groups. 30% are aged 18 to 29, 52% are aged 30 to 59, and 18% are age 60 and over. This mayoral candidate anticipates attracting 25% of this age group, 60% of this age group, 45% of this age group. Again, convert percents to decimals. All right, draw a tree diagram of the above situation. All right, I've already drawn it. Let me go through what I did. So here's the voter. Here are my age groups. There's 3 age groups, so 3 branches. At the end of each branch, we put what percent are that age group. So 0.30, 0.52, and 0.18. Okay, now they either, yes, they vote for the person, or no, they don't. So yes, no. Yes, they did. No, they didn't. Yes, they did. No, they didn't. In this age group, 25%, 0.25 voted yes. We do not need the no. 60% of this age group voted yes. 45% or 0.45 voted yes for that person in this age group. Again, we do not need to fill in the no's. First question. What percent of the vote come from 18 to 29-year age group? So you simply follow the path, this and this. They're this age and they voted for the person. Again, this is an and situation, which means you're going to multiply those together. So this times this, which gives us 7.5%. Okay, next age group, 30 to 59, do the same thing. You're going to go this times this. And you get 0.312 or 31.2%. Okay, the older age group, same thing, follow the path, 18%, 45%, multiply, 0.081 or 8.1%. What percent of the overall vote does the candidate expect to get? Take these 3 and add them together. Okay, this one or this one or this one. Okay, add them up. You get 46.8%. Hopefully I did the math correct on that. So, should the person win? No. The person got less than 50% of the vote. Okay. Less than 50%, they do not win. All right, let's keep going. All right, we've got a table here. We're going to do some conditional probability. So what do we have going here? We've got favorite candy at Columbia Heights High School. All right, we've got the top row is female. 450 females were surveyed. Male, 520 males were surveyed. We got Snickers, M&M Plain, M&M Peanut, Reese's Peanut Butter Cup. All right, and then we've got the totals also on the bottom. So first one is not a conditional probability. It's just asking what's the probability that a female was chosen. Well, there's 450 female out of 970, so 450 over 970. And always reduce. Okay, this one's just the probability of M&M Plain. All right, M&M Plain's right here. There's 105. that chose M&M plain out of 970 and reduce. Now, conditional. Snickers. Snickers is the condition. We only are looking at Snickers. How many male chose Snickers? So 220 over 420, reduce. All right, on this one, the condition is female. We only want to look at female. There's 450 female, that goes on the bottom. How many female chose M&M peanut? 40 out of 450. Reduce. 4 over 45. Okay, a couple more. We got now this one, it has to be Reese's. So Reese's. 340 Reese's. How many female chose Reese's? 150 out of 340. And reduce. All right, this time we are looking at the male. How many males chose M&M plain? So we're looking at the males only. M&M plain, 45 out of 520. And reduce. All right, let's keep rolling. All right, here we have tossing the 2 dice, and here are all the outcomes. I've already marked some of the problems on here. So the first one is, what's the probability that it is a sum of 4? All right, well, a sum of 4 would be 3, 1, 2, 2, 1, 3. So 1, 2, there's 3 out of 36 outcomes. Okay, remember there's 36 outcomes with 2 dice. So 3 out of 36. And again, always reduce. Sum of 8. All right. These 5 add up to 8. 5 out of 36. All right. Here we keep going. All right. The probability of picking a red marble is 0.25. The probability of picking a blue marble is 0.30. What's the probability of not picking red? Complement rule. Okay, rule number 4. 1 minus 0.25, which is 0.75. Not picking blue. 1 minus the 0.30. Not picking red or blue. Well, first red or blue. If you add them, you get 0.55. Now that's picking red or blue. But it says not picking red or blue. So you got to go 1 minus the 0.55, which is 0.45. 8. Let's say you have 10 pictures to hang on the wall in your house. Unfortunately, only 6 pictures will fit on the wall you want to use. How many ways can you arrange 6 pictures on the wall? Okay. Order matters. Okay. Arrange, order matters. So this is a permutation, 10p6, 151,200. Okay, review how to type that in on the calculator. You are in a sports tournament that has 16 teams. They will award trophies to the first, second, and third place teams only. How many ways can the teams finish in the top 3 places? Again, order matters. It is a permutation because there's a first, second, and third place. So 16p3, 3,360. The food class needs 5 students to judge the cakes that were made. 20 students volunteered. How many ways can 5 students be chosen? Okay, in this situation, order does not matter. You just need 5 people to judge the cake. So that's a combination. So 20C5. Okay, 15,504. Okay, back to that pizza problem. So Martino's Pizza offers a special pizza with 6 toppings. There are 15 toppings to choose from. Guido decides to order a different 6-topping pizza each day. How many days can Guido go without repeating a pizza with the same toppings? Again, order does not matter. So this is a combination. 15C6. The restaurant you are at offers 6 appetizers, 14 main dishes, and 8 desserts. How many ways can you order a meal? Okay, this is the counting principle. We simply take those numbers and multiply them together. You can order 672 different meals. You have 14 shirts, 10 pairs of pants, 8 pairs of shoes. How many outfits can you wear? Again, multiply those 3 together, 1,120. All right, last page. Okay, we are tossing a coin 1, 2, 3, 4 times. Here are all the outcomes. How many outcomes are there? Count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 outcomes. What's the probability of tossing 3 tails? Okay, those are the circled ones. We've got 1, 2, 3, 4. There's 4 out of 16, which is 1/4. What's the probability of tossing at least 2 tails? That means 2 or more. 2 or more. At least 2 tails, 2 or more. And that would be the check mark ones. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2 or more tails. Okay, I don't think I missed any in there. Nope. So 11 out of 16. What's the probability of tossing at most 3 heads? Okay, that means 3 or less. Up to 3 heads, 3 or less. Okay, well, that's 15 of them. Okay, I didn't mark those, but there's 15 of them. The only one you can't count is this one. You can't count that one because that one has 4 of them. So that means there's 15 left. Okay, last one. What's the probability of having all 4 tosses being the same? Okay, well, that would be this one and this one. So there's 2 of them. All heads or all tails. 2 out of 16 or 1/8. Again, it would be this one or this one. That's 2 out of 16 or 1/8. All right, that's it, ladies and gentlemen. If that was too fast, you can always rewind it and go back and watch anything that you missed or didn't understand. All right, good luck on your test, everybody.